Consider the following formula. Which of the following statements is true for this formula, assuming E and R are not equal to 0? To solve this question, we would need to isolate one of our variables on one side of the equal sign, which is already done for us. So that means R divided by 1/4 is the exact value of E, and we can substitute that value in for every value of E that we see in our answer choices, and that will help us find the correct answer. Before we start doing that, however, let's simplify this. R divided by 1/4 is the same thing as R times 4/1. Anytime we are dividing with a fraction, that is the same function as multiplying by the reciprocal of that fraction. And to remember that, let me rewrite the original. We had R divided by 1/4. You can use a phrase called keep, change, flip. Keep the original, change from division to multiplication, and then flip your fraction. That is how we got to R times 4/1. And R times 4/1 is equal to 4R. So we can rewrite our equation as E is equal to 4R. And now we can go through and find our correct answer. Answer choice A says E times R is greater than R squared. So let's plug in E. E is equal to 4R times R is greater than R squared. As we simplify, 4R times R will give us 4R squared, which is indeed greater than R squared, because these two values, if we plug in the same value, say it's 2, we'd have 4 times 2 squared is greater than 2 squared. These two values are going to be identical. 2 squared is equal to 4 no matter what we do. But on the right-hand side, we would be multiplying that number by another 4, thus it will always be bigger than the value on the left-hand side. And that is why answer choice A is our correct answer. However, for the sake of the video, I will go through and show you why the other answer choices are incorrect. For answer choice B, we have R plus 2 is greater than E, which we know is equal to 4R. Now let's use opposite operations or inverse operations to isolate our variable. This R is positive, so the opposite operation is subtracting R from both sides. If it exists in math, there's always one of them, so 4R minus 1R will give us 3R is greater than 2. And then 3 is being multiplied to R, so the inverse operation is dividing both sides by 3. These will cancel, leaving us with 2/3 is greater than R. Now the issue here is that a variable, unless we're using the equal sign, a variable could be any real number possible. So we can't enforce upon it a range and say that R is only less than 2/3. That would be incorrect. So B, in this case, is incorrect. For C, we have 2R is greater than, I forgot to get rid of the rest of the work up there. There we go. For answer choice C, we have 2R is greater than E, which is 4R. And this is not true because 4, our R's are the same value, but if we multiply that value by 4, since 4 is a bigger number than 2, this entire value on the left-hand side will always be greater, on the right-hand side, than the value on the left-hand side. So that makes answer choice C also incorrect. And finally, for answer choice D, we have E, which is equal to 4R, plus 1/2 is greater than R. Again, use inverse operations to solve for our variable. We will subtract 4R from both sides. These will cancel, giving us 1/2 is greater than 1R minus 4R would give us a negative 3R. Then we would need to divide both sides by negative 3, because that is the opposite of multiplying negative 3 to R. And here we're going to need to do another instance of keep, change, flip, or multiplying by a reciprocal because we are dividing with fractions. So we have 1/2 divided by 3/1, which is the same thing as 3. Let me make that negative. We'll need to keep our first number the same, change the multiplication, and flip our fraction to be 1/3. Then we can multiply straight across. 1 times 1 gives us 1. 2 times -3 gives us -6. And therefore we have 1/6 is less than R. And be very careful here. Whenever you're working with inequalities, remember that if you divide by a negative number across the inequality, you then have to flip that inequality. Either way, this answer is incorrect because, again, unless we have an equal sign, there cannot be a specific value imposed onto R. Variables could be any possible real number. So this is incorrect, making answer choice A our correct answer.